All right, hello, my wonderful students. This is foldable number 3 from the list of tangent, sine, and cosine. This is the tangent function. And this is the equation that we are going to be using for this one here before we get into the crazy phase shift plus k ones. All right, so we're going to go ahead and go here. All right, once again, so we're going to be graphing this y is equal to tangent of theta, and we're going to be using the form of y is equal to a tangent of b theta for this one. And once again, so for this one here, since it's the parent function, this is going to be 1 here, and this, our b is going to be 1 as well. So a is equal to our amplitude. And for this one, of course, our a is 1, since because there's no constant here. That means we can do 1 times the tangent of theta. And for tangent, when we're doing our period, is going to be equal to pi over b. I know for sine and cosine, it's 2 pi over b, but tangent has a different period. So it's going to be pi over b, which is equal to, since there's no b here, it's going to also be 1. So it's going to be pi over 1, which is equal to just pi. So that's going to be our rate, or sorry, our period for this one. Tangent also starts at 0, 0, so we can go ahead and put our point here. And unlike cosine and sine that usually start here and move to the right, tangent actually has a point in the middle. So if we look at our points on this one here, we'll start here at 0 again. This is going to be, let's put these points out first, 1, 0. It's going to be our 0, 1, negative 1, 0, and then our 0, negative 1. And if you look at this here, the period, like once again, is pi, but this is here right here, right? So in order to figure out the distance we're going to need to go either way, we're going to have to divide this by 2. So we're going to have pi divided by 2, and coincidentally it's just pi over 2. So we're going to go this way, pi over 2, and we're going to go this way, negative pi over 2. Okay, and then that relates to this one, this right here. Because if we were looking at pi over 2 on our unit circle goes to here. And if we remember correctly, tangent of theta is equal to sine theta over cosine theta. And if we were to do this here, this would be 1 over 0. But you can't do this, it's undefined. That means this at tangent of pi over 2 is going to be undefined. That means there's going to be an asymptote period. That means our tangent graph will never cross this line. But if you look at this one here, negative pi over 2, it's the same thing, because if we go negative pi over 2 this way, we still hit this point. And this is going to be negative 1 over 0, or negative 1 over 0, which is also undefined. That means that tangent will also never cross this line. Okay. So now we can go ahead and graph the points that are inside. So we have a point here, but we need more points of reference. So the easiest thing to do is to graph the 2 points in the middle here, which this is going to be negative pi over 4. It's going to be positive pi over 4. Well, if you guys remember, pi over 4 is the 45-degree angle here, or we can just leave it as the pi over 4. And this, the point here, is radical 2 over 2 and radical 2 over 2. Well, if you take the sine of that, or sorry, the tangent of that, it's sine over cosine. But radical 2 over 2 divided by radical 2 over 2 is just 1. So at positive pi over 4, it's just going to be, I'll just put here, 1. Make this one negative 1. It's just going to be here at 1. And at right here, negative pi over 4, it's going to be a similar point, but it's going to be 2 pi over, or radical 2 over 2, and negative radical 2 over 2. So if you were to have negative radical 2 over 2 over radical 2 over 2, we would get 1, or negative 1, which is the point we have here. And now we know we're going up. Because this is a tangent curve, we know that the graph is going to look like this. Nice curvature. So we can see that it's going from negative to negative infinity to positive infinity because of our arrows. And that's our range, right? Negative infinity to positive infinity. But our domain is within this here. Remember, this is only one cycle. So if you wanted to draw another cycle, just draw the same cycle on this side here or another cycle on this side here.